IQ scores for adults in America are normally distributed with a standard deviation of 15 and a mean of 100. We have a random sample of 50 American adults that's taken, and we want to know the probability that the sample mean of their IQ scores will not differ from the population mean by more than 2 points. So our standard deviation is sigma, so sigma is equal to 15, and we have a mean of 100. And we want to know the probability that the sample mean for these 50 people won't differ from this population mean by more than 2. So within 2 from 100 would be anywhere from 98 to 102. So what the question's really asking is the probability that the sample mean x bar is within the range 102 to 98. To find this probability, since we know we have a normal distribution, we will convert to a standard normal z by subtracting the mean from everything, which is 100, and dividing by our standard deviation, which for the sample mean we have sigma over square root of n, and the sample size here is 50. So we will take x bar minus 100 over 15 over square root of 50, and then our last term is 102 minus 100 over 15 over square root of 50. So the middle term is now a z, we've standardized, and the outside terms are the same value but positive and negative, negative 0.94 and positive 0.94. If you want the probability of being between two values, and you want to look that up in your normal table, you use the trick that says take everything to the left of the larger number, so the probability z is less than the positive 0.94. And that will have counted too much, so you subtract off everything to the left of the smaller value, so we'll subtract off the probability z is less than negative 0.94. So in our table we need the values for positive 0.94 and negative 0.94. Looking for the positive value first will be on the second page of your normal table. And so for 0.94 we get a probability of 0.8264. For negative 0.94 we get 0.1736. And so what we want to do is subtract those. So we have 0.8264 minus 0.1736 for a total probability of 0.6528.